Hey, what's up, guys? I'm going to show you how to do page 785, number 35, A and B. Okay, so what the problem is saying for part A is use Heron's formula to find the area of the triangle with side lengths 7, 10, and 4. So we're going to draw a triangle that has the side lengths 7, 10, and 4. And it's saying use Heron's formula to find the area of this triangle. And Heron's formula is the square root of s times the quantity s minus a times the quantity s minus b times the quantity s minus c. S being the semi-perimeter of the triangle, which we're about to find, and a, b, and c being the side lengths of a triangle, of this triangle specifically. And so what the semi-perimeter is the perimeter divided by 2, semi-perimeter. So we're going to add up 10 plus 7 plus 4, and we get 21. And so you just divide that by 2. And so our semi-perimeter equals 10.5. Alright, so that is the semi-perimeter. Next, since we have the semi-perimeter and we know our variables a, b, and c are the side lengths of the triangle, we can go about solving the formula. So what we're going to do is we're going to start off with the semi-perimeter times the quantity of the semi-perimeter minus a side length of the triangle. So 10.5, we'll start with 7. So 10.5 minus 7 times 10.5 minus 10. Alright, and then our last one is 10.5 minus 4. We can't fit that up there, so we'll just put it down here. Alright, this is what your formula should look like. The semi-perimeter is 10.5 right here, times the quantity, the semi-perimeter, times the first side length, and then the semi-perimeter, the second side length, and then your third side length, 10.5 minus your third side length. So those are the side length 7, 10, and 4, and then 10.5 is your semi-perimeter. Okay, so we're going to subtract first. So clear that, and then we'll get 10.5 times the quantity 3.5, because 10.5 minus 7 is 3.5. And then we're going to get 0.5 because 10.5 minus 10 is 0.5. And then we're going to get 6.5 because 10.5 minus 4 is 6.5. Okay, so first what we're going to do is we're going to multiply 10.5 by 3.5. We'll clear this, and we'll get the square root of 36.75 times 0.5 times 6.5. Alright, since we just multiplied 3.5 by the 10.5, our semi-perimeter. Okay, so now what we're going to do is we're going to multiply the 0.5 by the 6.5. So when we do that, we get the 36.75 still here, and then that would be times by 3.25, because 0.5 times 6.5 is 3.25. Alright, and this is what it leads us to. And then what we want to do next is we want to multiply that. And so what you get after you multiply that is the square root of 119.4375. And Mr. Preachy told us to round to the nearest tenth. So after you do the square root of 119.4375, you should get around about 10.9 as the area. Alright, so that's our answer to part A. That is the area of the triangle with the side lengths 7, 10, and 4. And so now that we have to do part B, which says, show that the areas found for a 5, 12, 13 right triangle are the same using Heron's formula and using the triangle area formula you learned earlier in this lesson. So we know Heron's formula, and the triangle area formula is just simply 1/2 base times height. Alright, so first what we're going to do is we're going to do Heron's formula again, except for this 5, 12, 13 triangle, which is also a Pythagorean triple. Right triangle. Okay, so let's do the semi-perimeter. So 13 plus 12 plus 5, that equals 30. And we divide by 2, and we get 15 as our semi-perimeter. That's going to be our S variable again. Alright, so let's fill it in. So 15 times 15 minus 5 times 15 minus 12 times 15 minus 13. Alright, so that is the semi-perimeter right here. And once again, the first side length, the second side length, and the third side length, all subtracted by the semi-perimeter 15. So 15 minus 5, 15 minus 12, 15 minus 13. Okay, so after you subtract all of them, we're going to clear this. You're going to get 15 times 10 times 3 times 2. Alright, so then what we're going to do is we're going to multiply the 15 and 10. Okay, so let's redraw this. We'll get square root of now 150, 15 minus 10, 15 times 10 is 150, times 3 times 2. Okay, so now what we're going to do is we're going to multiply 150 by 3. Alright, so now we still have the square root. We're going to get 450. 150 times 3 is 450. And that's going to be times 2. We still have the 2 left. And so when you multiply 450 times 2, alright, we get 900. So we're going to end up with the square root of 900. And the square root of 900 happens to come out perfectly to 330, I mean. So that is the square root of 900. So we found the area of a 5, 12, 13 right triangle using Heron's formula. Now we're gonna use it times with the formula 1/2 base times height. All right, so 1/2 base times height. All right, so in the triangle, 5, 12, and 13. 5 will be our base, and 12 will be our height. So this is our base. This is the height right here. Okay, so let's fill it in. 1/2, 5, times 12. Okay, so after we get that, we get 1/2 times 60. Alright, and after we get that, 1/2 times 60 is 30. And 30 equals 30. 30 from the Heron's formula, and 30 from the 1/2 base times height formula. So this is the formula we used in Heron's formula. Put an H to represent this formula. And this is the 1/2 base times height formula. And they are the same. And we just answered B, which said show that the areas found for a 5, 12, 13 right triangle are the same using Heron's formula and using the triangle area formula you learned earlier in this lesson. So this will be the triangle area formula. This will be Heron's formula. And we just showed that they are the same. Alright guys, this is an easy problem, so hope you guys learned a lot from it.